So what is the data modeling? So, data modeling is nothing, but for example, if the business users will give us the business-related terms, business-related terminologies, she knows the business and she wants to convert the business into a model data model. So how to convert that? So we do have a different methodology to draw this to create a data model. So we do have 3 different methods. So one is called conceptual model and logical model and physical data model. So what it does mean? So what is conceptual model? So how to create this conceptual model and what is logical model? What is physical model? We will see one by one. You assume that. So we are going to create the data model for one of the particular online portal or something. Okay, so online portal, the online product selling portal, we are going to create this online portal, right? Definitely. They need to have, so these are all the tables we should have. So in order to have our customers' informations, we need to have the customer table in order to maintain our employees' details. We will have the employees tables in order to maintain the customers' accounts. We will have the accounts table. Now, to maintain the product information, we'll have the product, the region table. So to have the different regions on the sales, to analyze which region is performing well, to analyze which product is performing well. So which account they have transferring the money or doing the transaction the money, which employee is doing well. So how is the performance on the customers? Okay, so like this, we do have a lot of tables involved in the data modeling. So if you consider these tables, so countries tables, table regions, table counts, table merchant table, so a lot of tables are available. Okay, so in this customer table, so each customer will be identified by customer ID. So this ID, we will call it as a primary key in a database, so then we will have all other information of our customer. So for example, customer name, so customer name might be a duplicate. Okay, so 2 customers may have same name, but the customer ID will be different. The customer mobile number, we can get the customer mobile number to give them the update. The mobile number, we can get the date of birth of the customer to identify, to analyze the age of the customers. So which type of customers, which age group of the customers is ordering the product more? So in order to get that, we need to have the date of birth, so we will get the address of the customers, which location their customers are ordering more on, the city of the customer and country of the customer from different countries. So these are all caused the different dimensions. Okay, different dimensions of the customers. So if you consider customer is one of the table, then this is a customer ID is a primary key. So primary key in the sense it will not allow duplicate to the columns. So primary key and customer name, the mobile number, the date of birth is the different dimensions of the customers. This is a dimension table. We do have an employee table the same way. Employee ID, employee name, mobile number, employee skill set, employees of experience, and employee city address, all those we can get at the account. The account number will be the primary key, and what is the type of account, what is the active account or inactive account. So different details, we can get the accounts. So these are all the tables are dimension tables. Okay, so different dimensions of the data, and by using these dimensions, if I'm going to create a sales, this table is called a fact table, since fact table will have the each key values here. Which customer has ordered the product, okay, which employee has helped to purchase the product, employee ID, then which product he has purchased, product ID, then which account number he has purchased, which region he has purchased the product. So at the end of the day, I want to analyze the summarized data on the regions, which region is performing well, which merchant is performing well. I will have the merchant ID. This is the way I will get all the key values from the table. Okay, key values from the table. So these key values are called as foreign keys. Okay, the integrity, to maintain the integrity we'll have the foreign keys. So normalization, we will see more on the primary and foreign key. But as of now we understand this. Foreign key, primary key relationship. So each column is called as foreign key. That is, the reference is coming from the base table, the dimension table. So this is like the fact table. We have all the keys, and then we do have the quantity, how much quantity he has purchased the product. Okay, for example, 2 quantities he has purchased. What is the 1 quantity unit price? 1 quantity unit price, and what is the total quantity? So if 2 quantities is purchased, 1 quantity is $100, then the total price will be $200. Okay, so these 3 are called it as the measures, the measurable values. These 3 are called the measures. Why? Because these are the measurable values and this column is called as the dimensions. So these are all like the foreign keys will be maintained in the fact table. This is a fact table. F_sales is the fact table. The fact table is derived from the dimension table to have all the customer's information, the employee. We will not keep all the customer's information here. Just we will keep the customer ID, which customer he has purchased which. Employee has purchased help to purchase which product has been purchased and which account number from which account he has purchased, which region ID and which merchandise. All those, in order to after that, if I want to get this particular total sales for the day, so even I will use the date key. Okay, date ID or date key to have the date. So date dimensions, you will get the date. So which date? So after that, so I will combine, I will sum up this total price for a particular day, and then I will get the merchant on the ranking and I will go for the merchant ID join with this merchant table and then get which merchant is having the highest sales today. So this is what the FAT and dimension tables are related. So again, the data modeling is having the 3 different types on its conceptual model and logical model and physical model. So what is the conceptual model? So you have concept, okay, you have business concept. So I want to create a data model for this particular business. You take the online food delivering the business, online food delivering business. So this is one of the concept I have as of now. So for this I want to draw a model, data model. So what are the tables needed for this food delivering particular business? So, I will have the time, I will have the date and time dimensions, I will have the product, okay, different product I will have the different store to purchase the product, all those. So whatever the dimension tables you needed for this particular business, you will draw all the dimension tables like time dimensions, product store and regions and the merchant account, whatever the dimensions you want to have, you have to draw all the dimensions. So with that only name, okay? Only name. No need to mention any detailed informations. Okay? So these are called as entities. Entities is nothing but tables. Technical word is table, but in the conceptual data model, we will call it as entity. So what are the entities we are going to have? All the entities we are going to draw. Okay, so includes the important entities and the relationship among them. Okay, so what is the relationship we are going to create? So the tables are like divided into 2 parts. One is the upper. The path is having the primary keys. So whatever the keys you want to have. For example, this product table might have the product ID. The store table will have the store ID, the sales table will have all the foreign keys here. So this is what the conceptual diagram we will write. So here we will not write any attributes. Attributes is nothing but column names. Since it is a conceptual data model, we are not going to write any primary keys, farm keys, all those. We are just mentioning the entity names and how the entities are related to each other. So this is called a conceptual model. So you can have a simple paper and paint pen to draw this, or you can have this paint, okay? So just you can drag and drop all those and then you can have this conceptual data model. In this conceptual data model, it will be highly abstract, okay? So it will be highly abstract. So you cannot have any column names. You cannot have any column names. It will be easily understood. It will be easily understood, each and every model. So this conceptual data model will have this highly abstract, okay? It will not have any attributes names. Since the field name the column names, it will be easily understand. You can easily enhance. So you can add more entities to the particular model. Okay, so only the entities are visible. So you should not write any. So it's like a first step of the data model. So we will have all the entities. So only entities, we will draw all the relationship between the table's entities. So no software tool is required to define a conceptual data model. Since it is only the concept, we will not need to have any software tool to draw this. So this is one of the conceptual data model. So time, product, sales, stores, regions, account, merchant, so any number of tables can be connected with the fact tables. The fact tables might be connected with different dimension tables as well. So this is called the conceptual data model. Then we have the logical data model. In this logical meta model, it has been enhanced from the conceptual data model. So the first step is we will draw all the conceptual data model. After that, in this conceptual data model, we will have this. What is the primary key we will use? Okay, so definitely each entity, we need to have a primary key for this time dimensions. We will have the date primary key, date key in product, it will have obviously it's a product ID. So it is like a description of the column, not the column name, not the exact column name you will write. So simply we will write product ID, okay, with space. Also if it is a column name, so definitely, if it is an attribute name, definitely we should write with underscore. So since it is a description, so you can write with this. Okay, so date descriptions, month descriptions and year, week, all those. So whatever the attributes you want to have, you can have all the attributes here. In the product table, in the product entity, you can have product ID, product description, category and category descriptions, unit price, created time and updated time. You can have all those under the sales, the store, right? The store ID, store descriptions, which region is from the store, the region name created, it, updated, all those, you can have it. And then the store, as I told, the upper part of the fact table will have all the foreign keys. So from the store table you'll have the store ID from the product table, you'll have a product ID from the time table, you'll have the date key after that item sold, item amount, I told, right, it'll be the measures, only the measures, the foreign keys and measures will be there on the fact table. So item sold is the quantity, again, the sales amount is the price. So these two are called as measures, foreign keys and measures will be maintained on the fact table. So this is what we will maintain in the logical data model. We will not write exact column names, we will not write any primary keys and all those, we will simply mention that the column description, it includes all the entities and relationship among them, all the attributes in the sense, the column names, all the attributes for each entity are specified. The primary keys for each entity is specified. The farm keys are identified and specified with this fact table, and normalization occurs at this level. Normalization in the sense. Okay, so for example, I do have store table. I'm assuming that in the store table I have the region and region name. Okay, so I can split this store table into one more table. Okay, consider this is called an organization. Anyhow, we are going to see tomorrow. So consider this is one more table. As the region table we are creating, so the region table we are creating here, okay. And this region table, so we are going to delete these two fields from this table. And here we have only have the region ID, okay. Region ID column, so this region ID is connected with this region ID in this table. So this is region ID. We have region ID and then region name. So, a single dimension table is again splitted into other dimension table to have to avoid the data redundancy. So how we will avoid the data redundancy? Because if I have a particular store in a different regions, so I do have different regions, and in a single region one have multiple store, 100 stores are there in a single region. So the 100 regions informations will have 100 times the region names will be repeated. To avoid this, we will have only the region ID here, and we will take that region name only one time here, region ID, and read region, so that the data redundancy will be avoided by using the normalization. So this is called normalization. So normalization occurs this level. So if any possibility of the normalization on the tables, we will split up this table into multiple tables. This is called logical data model. So presence of attributes. So definitely we'll have the attributes present in each entity and the key attributes, the primary foreign key and non-key attributes. The description you will have, the non-key attributes you'll have, these are all the non-key attributes. This date is the key attributes. Here the product ID is the key attributes. Then primary key foreign key relationship definitely will have a primary key and foreign key relationship. And user-friendly attribute names. You can have only the descriptions. No need to have the primary and current key, No need to have that entire column name. You can simply have these descriptions and it will be more detailed than the conceptual model. So you'll have all the column names, right? So by using data modeling tool like Urban, so this is the tool, we are going to see this tomorrow. So Airwind is the data modeling tool or Power Designer, can be used to create logical data models. So this data model we are going to create and then this can be automatically converted to a physical data model with the help of this tool. So if you create the logical data model, so only this model, then the Airwind tool will convert this model into a physical data model, So it will create the table names, all those it will create columns. So this is the physical data model. See here. So each and every table will have the column attributes as well as the data type of the attributes, and data length of the attributes. For example, if you consider this is one of the table, the time table. So here the table name is mentioned as dim_time is nothing but dim is nothing but dimensions. So dim_time, dim_product, fact_sales. As I told, the sales table will be a fact table. This is the actual format we will give. So deep_store is a dimension table. The dimensions tables are connected with the fact table here. So see here we have all the column names underscore with underscore, the exact column name should be there. So what is the data type? For example, it is an Indeed chair or it is a backer. So how much is the data length? That is also be provided here. So detailed the logical model from the logical model, the physical model will be automatically drawn by using any of the data modeling tool. So we can have the Urban tool. So if you give this for the tool, if you give this model, so automatically it will convert that into this model. This model of data. So fact_sales. So definitely it will have the fact tables. So all the foreign keys again it is also integer, the integer and float. So mostly how the ID columns, the key columns and the digger dimensions. So is the specification of all tables and columns will be maintained in this physical data model. The farm keys are used to identify the relationship between the tables and denormalization may be occurred. Denormalization is in the sense we have splitted the tables, right? Two tables here might be merged these two tables into a single table. So if necessary, we will do this denormalization based on the requirement. So physical consideration may cause the physical data model to be quite different from the logical data model. So the physical data model again it will differ from each database. If it is generated might be the value it should be the integer big integer. But if you say Oracle, the integer might be number, the webcast might be backcast too. So different databases. So whenever you are having the turbine tool, if you create the logical data model, we should select what is the database. We are going to apply this. So if you select Oracle, then based on this particular database it will convert that logical into a physical data model. So this is the physical data model. It will create then so entities referred as the tables here. So again we will call it as since it is a physical table. So here we are going to make the technology says table. Here we will not call this as entity, we will call it a table. Attributes will be referred as column here. So database again compatible the table names, database compatible column names we need to provide, and database specific data types also mentioned, so difficult for users to understand. So those who do not have any technical knowledge, so they were somewhat difficult to understand. But if they are seeing that they can able to understand what is this column, so overall they can able to understand, but in detail level they could not able to understand again. We can create the index constraint triggers or the DB objects with this physical data model. So the create table structure has been created automatically for this create physical data model by using any of the tool. And this is what the tool will create, the automatically logical data model to physical data model of the different versions, different database servers. So this is the concept of 3 different data. A model.